Picture the metallic sound of a heavy train in the early morning, steel wheels vibrating, brakes releasing warmth, and echoes crossing valleys, plantations, and cities. Now transfer that sound to a map instead of just connecting two neighboring cities. This train travels through mountains, savanna, and forest in Brazil, then crosses the Andes to reach the Pacific Ocean on South America's western coast. This is the promise of the Brazil-Peru Bi-Oceanic Railway, a freight corridor connecting the Brazilian Atlantic to the Peruvian Pacific, with China as a strategic partner. In December 2024, here at Construction Time, we showed who was at the table, the general overview of the route, and how the Fiol and North-South railways fit into this puzzle. Negotiations advanced, studies took shape, and the challenges became more evident. The question is simple: were there advances in 2025? Stay with us for the next few minutes and we'll update you step by step. What is the current status of the Chinese railway that promises to cross Brazil? Instead of thinking of this project as one of the largest railway constructions on the continent, it's worth imagining a different picture. A long steel thread cutting through South America point by point until it turns isolated places into part of the same line on the map. This thread starts in the region of Ilhéus in Bahia, where the West-East Integration Railway, Fiol, connects to the future Porto Sul on the Atlantic coast. The Bi-Oceanic Railway travels through the country's interior, crosses western Bahia, enters Goiás, and links to the North-South Railway. It goes up toward the agricultural heart of Mato Grosso in the region of Lucas do Rio Verde, and then it heads north, seeking a connection with Rondônia and Acre until it reaches the border with Peru. On the Peruvian side, the idea is that this steel line will cross the eastern part of the Andes Mountains and go down to the port of Chancay on the Pacific, a deep water terminal built with Chinese capital, prepared to receive large draft container ships. We're talking about something between 4,400 and 4,500 kilometers of integrated railway, according to estimates from infracepal studies and federal government projects. For the Bi-Oceanic route, the backbone connecting two oceans through the continent. But these numbers don't come out of nowhere. They address an old problem in Brazilian infrastructure. To see why this railway attracted so much attention, we need to look back in history at the project's real motivation. The root of it all is a paradox that has haunted Brazil for decades. A country with continental dimensions, a major exporter of commodities. But that still depends disproportionately on long, congested, and expensive highways to take its production to the coast. When you open the national railway map, it becomes clear that something doesn't add up. The network exists, but it's fragmented with large gaps, especially in rapidly expanding agricultural regions like northern Mato Grosso, Porto Grosso, and parts of the Central West. Trucks travel thousands of kilometers to ports like Santos, Paranaguá, Itaqui, or Arco Norte, making each exported ton more expensive and increasing the country's logistical vulnerability. At the same time, trade with Asia has exploded. China has established itself as Brazil's main trading partner, buying grains, minerals, meat, and pulp. But the traditional route through the Atlantic, the Panama Canal, or the Cape of Good Hope is long, subject to bottlenecks, and more expensive. Soon, a bi-oceanic corridor connecting the Brazilian interior to a Pacific port shortens the route, reduces travel time, and relieves pressure on saturated routes. Before talking about a Chinese railway crossing Brazil, the first step was to integrate what already exists or is under construction. Fiol in Bahia, FICO in the Midwest, the North-South Railway as the main axis, and the highway corridors Brazilian Federal Highway, 364, and Brazilian Federal Highway, 317, which currently connect to Peru. For China, logistics is strategic. Linking a Pacific port directly to Brazilian production areas cuts travel time by days and boosts global supply chain security. In 2024, that was still the overall vision. The 2025 update marks the turning point when this discourse begins to be translated into formal studies, deadlines, and responsibilities. But what progress has been made in this regard? In 2025, the Brazil-Peru Bi-Oceanic project advanced from general talks to a formal study program. Brazil and China signed a multi-year memorandum of understanding involving Infra-SA and Chinese railway planning institutes, focused on evaluating the technical, economic, and environmental feasibility of a railway linking Bahia's coast to the port of Zancay in Peru. Here, it's worth noting that this is not a project currently underway, nor is it mere speculation. It's a project that stands a step above mere political discourse. However, as studies progress, the obstacles also become clearer, much clearer. The first major challenge is the geographic and geotechnical one, from the interior of Mato Grosso to the Peruvian border. The potential route crosses areas with varied terrain, stretches of the Amazon rainforest, mighty rivers, and finally, the monumental slope of the Andes. For a heavy freight railway, it's not enough to just connect points on the map. You have to respect limits on inclines, curve radii, slope stability, and the risk of landslides. This pushes the project toward a robust package of tunnels, viaducts, and containment structures. The second obstacle is environmental and social. Part of the corridor would cross sensitive biomes, preservation areas, and territories of traditional communities and indigenous peoples. This implies highly complex licensing, prior consultations, mitigation programs, and possibly route revisions to avoid more critical areas. In other words, any mistake here means years of delays, lawsuits, and heavy additional costs. The third challenge is economic and regulatory. A railway this size needs investments of tens of billions of reais. To make this work, it's necessary to ensure long-term cargo volume, legal certainty, clear accounting, and concession rules, and a delicate balance between public, private, and foreign capital. Without this, the risk is that the project will become just a collection of intentions, without the ability to actually reach the construction site. Once these three challenges are overcome, then yes, it's possible to talk about the possible technical paths. In the Brazilian section, the trend in projects of this size is to work with broad gauge and design standards compatible with FIOL and FICO, allowing for long, heavy trains with good commercial speed. In flatter areas of the Midwest, the focus would be on large earthworks, designing stable plateaus, efficient drainage, and engineering works to cross rivers and areas. As the railway approaches regions with more rugged terrain, especially in the transition to the western Amazon, and later in the ascent of the Andes, the technical design reaches a new level. There, a network of tunnels controls slopes while high viaducts cross deep valleys. Half-slope galleries, retaining walls, and a slope monitoring system, rain and soil stability. Everything is built to keep the train safe in a hostile environment while maintaining performance on the Peruvian side. Crossing the mountain range would require a combination of medium and long tunnels. Alignments in mountain ranges and intermediate yards for train crossings, always respecting slope limits and ventilation in long tunnels. In fact, throughout the entire backbone, modern signaling systems, operational control centers, and intermodal yards guide the interface between trains, trucks, and ports. The obstacles are significant and well known. Though complex, the technical solutions are similar to those used in mountain railways and major export corridors worldwide. This scenario lets us compare the Bi-Oceanic Railway to other projects in Brazil and abroad. When comparing the Sino-Brazilian project to other major Brazilian railways, the main reference is the large structural lines already operating or under construction. The West-East Integration Railway, will span 1,527 kilometers, linking Bahia's interior to its coast. The Central-West Integration Railway, in its main sections, exceeds 1,000 kilometers as it connects that region to the existing network. The North-South Railway, which crosses the country from north to south, totals 2,184 kilometers. The Bi-Oceanic Railway, with these and other segments to the Pacific, nearly reaches 4,400 to 4,500 kilometers of tracks. It's like taking the distance from São Paulo to Belém, Pará, and adding more, almost reaching the border with French Guiana. Or to put it more directly, it's like connecting three strings in a continuous line from the Atlantic to the Pacific. In Brazil, even a major controversial project like the 900-kilometer ferrogrão seems small by comparison. It's important as a specific grain corridor, but the Trans-Oceanic Railway operates on a whole different scale. It's an axis that transports cargo and connects several corridors together. The Brazil-Peru Bi-Oceanic Railway is a mega corridor like China's Qinghai-Tibet Railway on the international stage. In terms of length, something around 4,500 kilometers is practically the distance from Lisbon to Moscow. You can imagine a train leaving the Portuguese capital, crossing Spain, France, Germany, Poland, and entering Russia until it reaches the Moscow region. That's the scale of the railway being discussed today between Brazil, Portugal, Peru, and China. These comparisons put the challenge in perspective. We're not talking about just another regional branch, but rather an infrastructure project that, if it comes to fruition, will automatically be among the largest freight rail corridors in the world. If, at the end of the studies, the Bi-Oceanic Railway is considered viable and moves forward to the executive project and construction, the economic impact will be felt on several levels. The most direct is the competitiveness of agribusiness and mining, shortening routes to Asia, reducing travel time, and lowering logistical costs per ton make Brazilian products more competitive in contested markets. But the project is not just a line connecting 2 points, it works as an integrative axis. By connecting railways and highways, waterways, and ports, it increases the number of logistical hubs within the continent. Cargo terminals, warehouse hubs, processing centers. This means more services, investments, and jobs for cities that are currently seen only as highway junctions. All of this, however, depends on a critical step: turning memorandums into contracts, studies into projects, and projects into real construction sites. The 2025 update of the so-called China Railway, which will cross Brazil, shows a project that has not yet become a construction site, but it's now backed by formal studies, responsible institutions, and risk analysis, not just talk. This remains a high-cost, high-risk, high-impact gamble that requires a lengthy technical and organized process to become a real railway. Thanks for watching. What are your thoughts on this major railway being built in Brazil with guidance from China? Is it viable for the Brazilian population? Yes or no? Leave your thoughts in the comments. I'll make sure to read all of them. I'll stop here. A big hug and see you in the next video.